Hi, welcome to the session 8 on the core Java tutorial series. We were discussing about the various memory areas which is present inside of the JVM. So we have discussed about the method area, the heap area and the stack area in detail in our previous sessions. In today's session, we'll be covering the topics PC registers and native method stacks which are a part of the JVM's memory area in detail. So what are PC registers? PC registers are also known as program counter registers. So for every thread, a separate PC register is created. So this is the point 1 pertaining to this PC register. For every thread, we have one PC register created. Okay. So a Java program can be a single threaded program running on the main thread, or can be a multi-threaded program running on two different threads. So for each thread, for a multi-threaded program, for each thread a separate program counter will be created. So for thread T1, say for instance the program has two threads, thread T1 and thread T2. So for thread T1 there will be a program counter 1, and for thread T2 there will be a program counter register 2 which is getting created. And for a program which is having a single thread, only one PC register will be created or allocated space. So what these PC registers actually hold? These PC registers actually hold the address of the current executing instruction. So this is our second point. PC registers holds the address of the current executing instruction. Let me show you an example of a multi-threaded program. So here we have a multi-threaded program. Here we have a class multi-threading demo which extends the thread class, and as a result of extending the thread class, the run method has been overridden. So a multi-threaded program, a single thread of a multi-threaded program will be executing lines from this run method only. Okay, these statements which are written inside of this run method will be executed by two different threads, say for instance thread T1 and thread T2. Here in this programming example, we have a for loop, and the for loop runs for 8 times. That is, 8 multi-threading demo objects are created and started. That means there will be 8 different threads for this program. So for this program, 8 different program counter registers will be created for each thread. So the instructions which will be stored inside of this program counter registers will be from this area, the lines which are present inside of this run method. Okay, so the program counter register holds the address of the current executing instruction. Once the instruction or the current executing instruction, once the execution is complete for the current executing instruction, then the PC register gets incremented to store the address of the next instruction. PC register. So let me write down this point. Once the instruction execution is complete, the PC register updated to store the next executing instruction. Right. So this is all about the PC register in detail. Now let's move on to the native method stack. For every thread, JVM will create a separate native method stack. All native method stack calls performed by a thread will be stored inside of this native method stack. As we know, or as we discussed previously, that a Java program can be a single threaded program or can be a multi-threaded program. So for each thread, there will be a native method stack created. So for a multi-threaded program, if we have two different threads, say for instance thread T1 and thread T2, then we'll be having two different native method stacks created. and these native method stacks will be created at the time of thread creation and not before that. For a single threaded program, only one native method stack will be present. Okay, and these native method stack will store the calls of the native methods. By native methods we mean the methods which are written in C and C++ language. Okay, so the calls to this method will be stored inside of this native method stack, similar to the runtime stack mechanism in which the Java method calls used to be stored, as we discussed in the stack memory area section. Okay, so this is all about the native method stack in detail.